I had a few requests to go over proportions, so let's take another look at them. A proportion is an equation stating that two ratios are equivalent or equal. If a proportion contains a variable, you can use cross multiplication or the cross product property to solve for the missing variable. Here are a couple of examples. Again, I used words like the extremes and the means. We're basically just taking and cross multiplying. You're taking this top term and multiplying it times this bottom term. And we're going to get 5 times x. We're going to take this, the means, and take this term and multiply it by that. So we've got 6 times 10. So I have 5x is equal to 60, and we'll divide by 5. And we'll get x is equal to 12. That's the missing term that makes that proportion true. Now, looking at it in another perspective, if I have 5, 6, a 5 to 6 ratio is equal to a 10 to some unknown, what number would make this true? Cross multiplication works 100% of the time. Once in a while, you might see a relationship here, either multiplication or division. Well, 5 times 2 is 10, so 6 times 2 is 12, so x is equal to 12. Another way to look at it. It doesn't always work. Cross multiplication works all the time. Let's take a look at a second one. Again, we're going to use cross products. We're going to multiply these two terms. 6 times 8. We're going to multiply these two terms. That's why it's calling cross multiply. It's crossing over. I now have 48 is equal to 3x. Let's divide by 3 on both sides, and we get x is equal to 16. 16 will make this a true proportion. And again, looking at these two examples here, another way to recognize that two ratios are equal is if I simplify this to its lowest terms, divide by 2, and divide by 2, you see that these two are equivalent or equal. So there's several ways to look at this, and again, knowing more than one is always beneficial. All right, so now let's not solve for something in these first couple problems. Let's test out to see if they form a proportion. Again, two methods. I could use cross multiplication, or I could look for a relationship, or I could actually 3 methods, or I could simplify both. If I did the simplifying method, and again, I'll show you all of them, divide by the common factor of 2, I get 2/5. Let's divide by a common factor here, which would be 4. And I also get 2/5, so I see these are equal, so this forms a proportion. Method that always, or I could also see 10 times 2 is 20, and 4 times 2 is 8, or I could cross multiply. 4 times 20, does that equal 8 times 10? Well, 80 equals 80. It's a proportion. On to my second problem. Again, I'm going to do more than one method. Now this method that looking for equivalent fractions doesn't work because there's no number times 8 that will give me 12. I could, if I wanted to, simplify by putting these in lowest terms. Let's divide by the greatest common factor here, and that's 2, and that will give me 3/4. If I divide this by the greatest common factor, which is 3, once again I get 3/4. This is a proportion. The method that we're suggesting in your text probably would be cross products. Multiply and multiply. 6 times, but I'm showing you that there's other ways to do it, and you may already know them. This gives me 72 is equal to 72, and both methods worked. Looking at this last problem, I can't simplify either one, so chances are this is not a proportion because these two ratios are in simplest form and they don't equal. However, let's perform the cross products to prove it. I have 8 times 7. Does that equal 9 times 6? Well, 8 times 7 is 56, and 9 times 6 is 54. This does not equal, so this one is not a proportion. So I'm now giving you more than one method to test out to see if two ratios form a proportion. Let's go back to that solving. Solve each proportion for the missing term. You can use cross products property to solve. This is now going across. I've got 9 times x, and then I go across again, and I have 15 times 3. Looking for that missing term, dividing, and again, these are just some simple solving of one-step equations, and the missing term is 5. This next one has an expression, not an x alone. So again, I'm going to multiply here, but I have a distribution. No problem, because we've already covered all this. This is now 3x plus 6 is equal to 24. Let's go ahead and continue. And I get subtract 6 on both sides. Divide by 3. X is equal to 6. Now 6 is the value, but 6 plus 2 is 8, and that's going to give me the missing term. 2 more for you to try. Again, cross multiplication. 5 times x is equal to 7 times 3. 5x is equal to 21, and divide by 5. There'll be times when the missing term is a decimal, and this is one of those cases. Last one, I've got 10 times x minus 3 is equal to 5 times 6. Distribution comes first. Add 30 to both sides. You get 10x is equal to 60. Divide and get x is equal to 6. So hopefully this little review was just what you needed to refresh your memory on proportions. Today I want to move on to a special kind of ratio, and that's percent, because it's a ratio that compares a number to 100. If I had 75%, that would be 75 out of 100. Percent is per 100. You can write a ratio as a percent using the equivalent fraction method if the second term is compatible with 100. So now let's go from fraction to percent. Okay? If this bottom number is compatible with 100, which means it's on this list here, I can write an equivalent fraction to 100. I'm not even getting into the proportions right now, but again, we certainly could solve this as a proportion. But with this particular type of problem, it's equivalent fractions that I'm looking at, because this is times 20, and then 2 times 20 is 40. So this is a 40%. Let's see that again. Here, to go from 20 to 100 is times 5. I do the same thing top and bottom. When I multiply by 5, I get 75. What is that? 75%. 25 to 100 is times 4. Times 4 again. That's going to give me 68, and that's a 68%. 50 is also compatible with 100 times 2 times 2. That's 84, which is 84%. So writing the percent to a fraction is the reverse, which I gave you an example up on top. But if I had 12%, I would write that as 12 over 100. I would then simplify by dividing by 4, and I'd be done. I could have 5%. That would be 5 out of 100. Divide by common, the greatest common factor, which is 5. And there you have it. So what I'm looking at here is a special kind of ratio called a percent. We can convert these percents into fractions in lowest terms or decimals, or we can actually take our fractions and convert them into percents. Now, I mentioned, as in this top row, that I can, and I'll show you one more time, that we can use equivalent fractions with certain types if these denominators or the second term is compatible with 100. So in this top row, they're all compatible. But when we get to the bottom row, they're not. So there's where a second method is going to come into play. Times 10 times 10 is 70. Any ratio comparing to 100 is a percent. Times 4 times 4 times 5 times 5 times 2 times 2. I'm going to stop here because we meet in person today, so we'll go over this in greater detail.